In the previous videos, we mentioned about presenting the result in your thesis. You will need to choose an appropriate tools, either the tables or figures, to effectively present the informations, which is the outcome of your investigation program, to the reader. It is not only for the readers to easily comprehend your informations, it is also so that the readers can easily come back and searching for the respective informations as they read along to the following sections of your thesis. Different modes of data presentations have their own characteristics. If you are more concerned about the content or the precisions of the informations, it will be more suitably being presented through the text and tables. If you would like to bring impacts to the reader or draw the interest of the readers, the graph and illustrations it will be more useful. In general, tables are suitable for numbers. Figures is suitable for graphical presentations. In terms of the value, more precise number can be shown in the table, while figures can only demonstrate the relative differences between two values. We also mentioned about common mistakes while you're using the figures and tables. The root cause of this is that normally when students want to present their result in figures and table, they don't have a clear purpose of presenting it. This is either reflected by using the wrong type of method, providing with descriptive titles, missing important informations, and so on and so forth. It was mentioned also, when you present the informations in the table, you can actually utilize certain locations of the table for emphasizing purposes. There are certain rows or columns which is easier to draw attention to the reader. If you use those properly, you are able to highlight certain significant results, and this will bring the readers towards the directions of your discussions. Now let us see some examples of presenting the results. For example, this research, which involved the experimental study and computer modeling. There will be load applied onto the member, and the response onto the connections are observed. Same goes to computer modeling. The load is simulated, and then the response of the connections is also observed. What you see here is the simulated response is very identical to the actual response. Through comparison of these two, we will be able to identify the reliability of the computer modeling developed by the authors. There will be overlapping informations as given by the experimental result and the model result, which can be acquired from the deformations of the connections. You will use these overlapping informations to cross-check each other as a process to validate the models that you use to simulate the response of the connection. And then there will be unique informations given by different methods. For example, from the modeling here, you will be able to observe the stress contour, indicating the regions where high stress is concentrated. This will be helpful for you if you would like to propose improvement for the connections, as the high stress region normally represent the regions that has high chance of causing the failure of the connections. Then you may put your discussions focusing on those. This is an example of good presentations of the results, which straight away the reader will be able to acquire the core message behind presenting those results. This is another example of presenting the results, which is in the mode of the tables. You know that the advantage of the table is that the information can be presented in the matrix form in 2 dimensions, 1 and 2. The positions of the information given with respect to the 2 dimensions will represent the relevant information in terms of the relevant specimen as well as the relevant results. Another advantage of the table is that you can present the information in a high precise manner, which in this case there are 4 significant figures, which is quite okay in terms of the accuracy. More than 4 significant figures is not necessary due to the percentage contributed by the smallest interval to the overall value presented. You see there are several rows. Each row represents each specimen from specimen 1 to specimen 4. The first column here represents the experimental results. The second column here, it will be the model results. This is obtained from experiment, and this is obtained from modeling or simulations. In this case, the purpose is to verify the reliability of the model results. Therefore, there will be comparisons of the model result against the experimental results. The comparison is indicated by a ratio of the model result divided by experimental results. Normally, we put something that as a reference at the bottom of the divisions. The one that we would like to check for the validity, it will be on top of the divisions, which in this case, it is divisions of this by this. This number can easily be computed from Microsoft Excel, and then you obtain the list of the ratios as the comparisons of the results. And then how do you interpret this ratio? When the ratio is equals to 1.0, that means your model result is exactly the same as the experimental results. And when the ratio is less than 1, that means your model result is less than your experimental result. When the ratio is more than 1.0, your model result is actually greater than your experimental results. An advantage of having this ratio gives you a percentage of variations as compared to the experimental result. By looking at the number 1.03, we know that the difference it will be 3%. Your model result is 3% higher than your experimental results. Same go to 0.97. Now your model result is 3% less than your experimental results. With that, you have an idea in terms of the degree of variations between the model and experimental results. You may also use the mean and standard deviations in order to quantify the degree of consistency of the simulated results. Of course, you can go even one step further, setting the requirement for you to accept the degree of accuracy of your model results, and then to determine the percentage of the specimen meeting that requirement. This is of course based on the purpose of your study, And what you see here, the figures present the result in the graphical manner. It is quite difficult for you to present exact value of anything instead of the relative differences that we can observe from the diagram. By looking at the diagram here, we know that this part undergoes significant degree of deformations if we do relative comparison between this part. As for the table, the comparison can be made by comparing the exact numbers and can even be quantified in terms of the percentage after the computations of the ratio of predicted result against the experimental results. This is another way to present the predicted and the experimental results. You can actually plot the result in lines. One line is for the theory, another line is for the experimental results. In the case that your theoretical result is totally equals to the experimental result, both lines will overlap onto the same positions throughout the x and y axis, which in this case, the two lines traces closely to each other with some degree of variations. And you will observe that the theoretical results are normally slightly lower than the experimental result. You can say that the theoretical results would be more conservative as compared to the experimental results. The locations of the line also give you some meaningful informations. If you would like to go a step further in quantifying the degree of the accuracy between the two results, you can actually go forward to compute the R-square factors, which you know that the R-square equals to 1.0. It will represent that the result for the theories and the experimental are perfectly identical. This is another example of presenting the results. Now you have a line represent the actual response. Although there is a trend within the line, it is not really linear. Sometimes it is quite difficult for the researchers to express such a response, especially in terms of the complex curve, which is not linear in the mode of the equations. Sometimes the researcher will choose to simplify the response into some simplified model, closely trace the actual response of the specimen. By using this simplified model, you will be able to predict the response of a certain specimens close to the actual situations. As long as within a certain acceptable limits, the simplified model can be used. This is another example of presenting the results. It is basically an analysis of various analytical models. You will see there are analytical models proposed by different artists. There will be a total of 4 models here, as given by different equations referring to the same thing. And then there is a table here to present the results in the exact value in order to see which model is more accurate. I believe the artist is actually trying to compare his own model, which is this, with the 4 models that he have acquired from the literature review. He did an experimental study which yields him the result here based on his own model to compute the predicted response, and then he used the same set of the parameter, substitute into the 4 models proposed by 4 different artists, which acquire all these values. From here, he will be able to compare the model result against the experimental result in order to observe the degree of differences of each models with the actual results. Having quite a number of examples of ways to present the results, you will see something in common. Presenting a result is not just presenting some values as acquired from your investigation program. There are always a purpose behind presenting it. You will need to ask yourself, what do you want to achieve by presenting the results? How you would like to present it? And you will see that the right choice of the presentation tools, either by the table or by graphical manner, which they are all in one common conditions, where the concentrations of information is rather high. Imagine you need to produce these two tables just for one purpose. We are able to observe the degree of effort that you spend into acquiring this. This is how you're going to impress your examiners and supervisor. For you to be able to find so many models out of literature review, most likely you have done quite an extensive review from all the literature that is available, which you have done through the screening and filtrations. What is left over, it will be those highly relevant, and also those which is compatible for your study with the existing parameters that you have, that you can adopt into the equations for you to predict the result. And most likely those models are carefully selected out of a series of models which have did some prior tests to be not reliable or not suited for your conditions. And then you did an experimental study, having so many samples to be tested. You develop your own model, work out the predicted results, and then you substitute your relevant parameters into the models proposed by the previous researcher. You acquire a list of the informations representing each of the models. Then your next steps, most likely you're going to make comparison to observe the differences and to evaluate your predicted result, whether it is more reliable than the other existing model or it is less reliable than them. You might want to discuss further, why is it more reliable or why is it less reliable? Anything that you can do to improve your model to increase the reliability and accuracy of your own model. There could be some discussions of you to qualitatively compare your own model, whether your model is more complex or more simplified as compared to the previous researchers. There are so many informations that you can extract if you are able to present the informations properly. With that, in the case that you need to present your own result, your thinking should go one step further, not just presenting the results. You will have to consider later how you would like to address the informations presented in your tables or the figures.